Hi everyone, thanks for joining Presto Day and this session. Today I'm going to talk about running Presto on Kubernetes and how to do it in an easy way with Helm. I'll start with some high-level theory and end up with an actual demo. In the beginning, a few words about me. My name is Denis. I'm really passionate about data engineering, data infrastructure, and architecture. I have a solid Java engineering background. I like and I truly believe in DevOps culture. And last but not least, contributing to open source recently became my new hobby and addiction. So let's start with the question, why Kubernetes? To find the answer, we need to have a look at different application deployment options. This is classic comparison of the deployments in bare metal, virtual machine, and container environments. All three have infrastructure and host operating system. In a bare metal environment, you manage common binaries and libraries, and then deploy applications on top. Looks simple, but in practice, it can take hours or even days to deploy an application. Also, the applications are not isolated from each other, what might cause version conflict for some binaries or libraries. Virtual machines, in opposite to bare metal, provide necessary isolation between applications. So each application can use a specific version of required packages. Deployments take less time because virtual machine snapshots with pre-deployed applications can be used, but there is a significant overhead for guest operating system. This overhead is eliminated in the container environment. So alongside the required isolation level, you get an amazing speed up in application deployment. And I'm talking about few minutes or even seconds to run applications like web applications, databases, etc. Containers, however, don't solve scalability problem. The host, which is used for running containers, is still limited by physical resources it has. Also, single host becomes a single point of failure. So the solution is to use more hosts to spread workloads across the cluster and enable infrastructure for high availability and horizontal scaling. Of course, it doesn't come for free. With more hosts, there are more problems need to be considered and solved. It is required to have an orchestration infrastructure on top of hosts. We need common network, container monitoring and scheduling, some configuration system also. And Kubernetes solves these problems and actually many others. For example, Kubernetes simplifies containers usage in a cluster by introducing convenient abstractions. Let's briefly look at some of them important for this talk. And first of all, it's pod. Pod is a minimal workload that can be executed in Kubernetes. It's one or more containers on the same host, and those containers share IP address and volumes. In this simple example, there is a pod called web server that runs one container of a specific version of Nginx and exposes port 80. Deployment is the next level of workloads, which is used to run pods at scale. Instead of creating and managing many identical pods separately, the deployment resource defines how many pods to create, specification for those pods, and other configs. In this example, there is a deployment called web server, which manages 3 pod replicas running Nginx containers with port 80 exposed on each. How is the deployment connected to pod instances? By labels. The deployment uses label selector to group together the pods created with common labels. Last resource or abstraction I want to talk about is service. Service is used as a single point single entry point, and load balancer for network applications running on many pods. Service allows clients to communicate with distributed applications through one stable service name or IP address. In this example, there is a service called web server that exposes port 80 and routes traffic to application pods. How is this service connected to pod instances? The same way as deployments, by label selector and common pod labels. Okay, let's put all together. This is a Kubernetes resource definitions for our web server. Looks straightforward, but very powerful at the same time, because we have load balancer here and few automatically managed web server replicas behind it. I think this simplicity and power at the same time is a good answer for the question, why Kubernetes? However, we have one more small question. What is Helm? And what kind of problem does it solve? Actually, why do we need it? Imagine you have an amazing product, for example, Presto, and you want to run it in Kubernetes because someone told you it's super easy to deploy and maintain it there. You create all necessary Kubernetes resource definitions files like deployment, services, etc. Save them in Git for backup, of course, and deploy resources to Kubernetes development cluster. It works great, and you decide to deploy Presto the same way to production. It means you need to create all resource definitions one more time, just with a bit different configuration, that correspond to your production environment. For example, you want to add more CPU and memory, or you want to change some catalog properties for production usage, etc. Fine. But what if there are 3, 5, 10, or even more different environments and configurations? What if it's needed to change or add fields to all resources, to all resource copies? For example, you want to add new common label, then it becomes a problem. Following dry principle, don't repeat yourself, we can split resource definition and property values to have only one version of templated resource definitions and many configs, one config for each environment. Fortunately, we don't need to develop this from scratch, because there is a Helm, which is great implementation of the idea. Helm is a package manager for Kubernetes applications. It operates with concept and packaging format called chart. Helm chart is a collection of Kubernetes resource templates, default values, chart metadata, and few optional files. Chart packages are stored in repositories from where they can be retrieved and used by a few simple commands. Helm helps to manage very complex applications, such as web servers, databases, streaming platforms, and even bundles of them. There are tons of Helm charts for different products, officially and community maintained. And I'm happy to announce that Presto also has an official Helm chart now. The first version of it has been released a few days ago. Let's have a look at it and try it out. If you are curious about source code and want to know more about the chart internals, check GitHub repository of the chart. If you want to get started quickly, the first step is to use the chart is to add its repository to the list of known repositories in Helm. That's why, for these purposes, you should use Helm repo add command. Next command is Helm show. This command helps to know more information about the chart. For example, Helm show chart prints chart metadata, Helm show readme prints readme file, and Helm show values prints default values.yaml file, file with default values. Okay, I think it's time for demo. We will run these commands to see how it actually works. It's assumed that you have Helm command line tool installed on your computer. Okay. Let me open terminal. Okay. Put this command here. So here we add the Helm repository and name it Presto. Nice. Done. Okay. Now let's explore our Helm chart a little bit with Helm show command. Helm show chart from Presto repository and chart called also Presto. And here we see information about the chart like version, name, version, description, and other metadata. Okay, let's see default values. And there is a file with values.yaml which contains all values can be used in this chart. It also has some doc strings explaining what kind of property it is. Okay, let's come back to slides. And go to the next slide. Okay. Presto Helm chart supports 3 Presto deployment modes: single or singleton mode, cluster node, and also highly available cluster. Let's start with the first one. Single mode is a minimal Presto deployment mode where one instance or pod acts as a coordinator and worker. This mode is useful in environments with limited resources for testing or experimental purposes. If the chart installed in a single mode, then only one pod is created because number of replicas in deployment is locked to 1. And of course, there is a service in front of the pod. Yeah, let's install Presto in a single mode with the command provided on this slide. I'm using Minikube to run Kubernetes locally, and also have installed kubectl and Helm command line tools. Okay, let's go back to terminal. Okay, I'll copy it. So here we run a command called Helm install. We install Presto chart from Presto repository with name myPresto and set mode to single. Let's okay. Now, as you can see, Helm chart prints some information about the chart, about the actual deployment, plus some notes about the chart. And here you can find how to access deployed release. You can access it from inside and outside the cluster. We are interested in to access it from outside the cluster from my browser. So yeah, we will use this kubectl port forward command in a few moments. But first of all, let's have a look how our deployment is going. I'll run the following command, kubectl get pod, to see how many pods we have. Okay, now as you can see, we have only one pod, coordinator pod. It recently becomes ready, so we can use it now. So it's fully up and running. Okay, let's run this command kubectl port forward, which opens the traffic between Kubernetes cluster and my local computer. So let's run it. Okay, and let's open this UI. And as you can see, we can reach Presto on port 8080, and there is one worker pod up and running. Okay. So actually, it works in a simplest and minimal mode. Okay, let's uninstall the chart. We will install it like this. Done. And let's come back to slides. Okay, next mode is cluster mode. This is classic mode, which is used in production environments with one coordinator and many workers. The chart deploys Presto in a cluster mode by default, and with two workers by default. Let's install it also. Okay, terminal here, paste. Okay, we don't need to specify mode because cluster mode is a default value. I'll print it. Enter. Why? Just to show you why we don't need to specify cluster, because Helm show values. Presto / Presto. Enter. Let me scroll, and here we should see the mode. Yes, this is default value, mode cluster. And here we have explanation what kind of modes supported, etc. Yeah, but as you can see, it's cluster here. Okay. Now let's see how it's going with our pods. Are they up and running or not? kubectl get pod. Okay, here. Okay, and as you can see, we have one coordinator and two workers. They are running and they are ready. Their status is ready. Cool. Let's open port. Let's run port forward command again. And we expect two workers to be up and running. So here we should see two workers, and yes, it's two workers here. So the uptime is 1 minute. So it's fresh installation, etc. Yeah, standard cluster mode. Let's uninstall it also. And done. Okay. And the last one is the most advanced mode, highly available cluster, also known as disaggregator coordinator setup. In this mode, Presto supports multiple resource managers, multiple coordinators, and of course, a lot of workers. It allows to avoid a single point of failure and also mitigate coordinator bottleneck in high-load Presto clusters. Let's try it out. I'll install Presto in highly available cluster mode with two coordinators. Yeah, just to demo how it works. By default, there is only one coordinator replica. Okay, let's open terminal again. Paste. Okay, how to set more coordinators like this? Set coordinator dot replicas 2, and this command should install Presto cluster in HA cluster mode with two coordinators. One resource manager and two workers. Okay, let's see. Let's run kubectl get pod. Come on. Okay, and as you can see, we have one resource manager. It's default value, only one. Two coordinators because we set number of coordinators to 2 here. And two workers, default number of workers. Let's wait a little bit. Usually it takes like 50-60 seconds for up and running. As you can see, I mean, all of them are running, but not fully ready yet. Okay, and now all of them are ready. So coordinator, boss workers, boss coordinators, boss workers, and resource manager. Okay, let's run port forward command one more time, and we should see 2 workers again. Okay, port forward. Done. Let's update it. In HR mode, sometimes it's needed for all pods to be communicated with each other. So yeah, as you can see, uptime is 1 minute. We have 2 workers here. So yeah, it works. Let's open terminal, and yeah, just to double check that we have 5 pods here, 2 coordinators, resource manager, and workers. Okay, let's uninstall it also. Done. Oh, good. And yes, in conclusion, I want to highlight some initiatives and problems on the roadmap that need to be solved for 1.0 release of the chart. Of course, it's documentation, how to use the chart, how to contribute to the chart, etc. Testing. We need to have unit tests for templates. We need tests for Kubernetes compatibility. We need performance and integration tests also. So yes. Next is autoscaling. We can utilize elastic nature of Kubernetes and allow Presto to scale horizontally in runtime. So we can increase number of workers, for example, if we have a lot of requests, and we can scale down our cluster in the runtime also, for example, during the night to save more money and resources, computing resources and money. Prestissimo support, yes. Why not to enable the chart to be used with high performance native workers? And of course, there is a room for many other features and improvements. Maybe your improvements. Feel free to create bug fix issue, feature request, or PR in the chart repo to make 1.0 release closure. That's it. What I had to say and show for today. Feel free to ask your questions now, or also do not hesitate to reach out and connect in LinkedIn or Presto Slack. Thanks.